Welcome to the Deep Dive, where we take your pile of information and turn it into actionable insights. Today, we're plunging into a world that, maybe at first glance, might seem a bit dry.
Yeah, maybe construction law.
But it's absolutely foundational. I mean, foundational to every building, bridge, or project you've ever seen. From, the smallest home Reno right up to the tallest skyscraper.
Indeed. We're really talking about the invisible framework here, the thing that underpins the physical world all around us, this intricate web of contracts, codes, legal precedents, all governing construction.
Right.
It's the essential blueprint, often unseen, that keeps everything standing, keeps projects humming along, and crucially, keeps people out of court.
That's exactly it. So our mission today is to unpack the law of the job site. And look, this isn't just some basic intro. Think of it as an essential guide. It's the legal architecture that every single professional in construction, project managers, architects, contractors, everyone really has to understand. We'll explore the whole legal landscape. We'll dig into various contract types, uncover why defining scope is so critical, and dissect how disputes are resolved, or maybe how they should be resolved.
Yeah, that's a key distinction.
We'll even get into some really fascinating historical context and some, frankly, gripping real-world examples. Stories of how legal challenges have shaped iconic projects, even saved bits of history sometimes.
Oh, definitely. Some great stories there.
So by the end of this deep dive, you won't just know the rules, you'll get why they matter, how they impact everything from the budget bottom line right through to safety on the actual site.
Exactly. It touches everything.
Okay, let's unpack this. Before a single shovel even breaks ground, right? Or maybe even before the first line gets drawn on a blueprint, there's this whole legal universe already swirling around.
Absolutely. It's already in play.
And it's not just about, avoiding lawsuits, is it? It's much more fundamental. It's dictating how projects operate, how value gets delivered, how risks are managed. It's like this silent force guiding everything.
It really is. And what's truly foundational, as you said, is how these legal and commercial frameworks don't just set the stage, they actually define the entire play.
Define the play, I like that.
Yeah, they establish the boundaries, they clarify the expectations, they allocate who's responsible for what for all the parties involved. This whole intricate web dictates not just what gets built, but how it gets built, who builds it, under what conditions.
Right.
Honestly, without this solid legal foundation, any construction project, doesn't matter the scale, it would quickly fall into chaos, uncertainty, probably failure.
Okay, so if we're talking about the ultimate law of the land here in the construction world, where do we even begin? Like, what's the absolute top of the pyramid?
Well, you absolutely have to start right at the top with statutes and regulations.
Okay.
Legal scholar Julian Bailey really hammers this home. Laws made by Parliament or Congress in the U.S. context, they aren't just suggestions. They hold supreme authority. They actually take precedence over court rulings in many cases.
Wow. Okay, so legislation first.
Exactly. These broad foundational laws, think like a major Environmental Protection Act or maybe a comprehensive workplace safety law. Those are the statutes.
Got it.
Then, to make those statutes actually work on the ground, to make them practical for industries like construction, they get implemented through more detailed secondary legislation. And that's what we call regulations.
So the regs are the nitty-gritty.
Precisely. They give you the granular rules, specific limits on, say, construction waste disposal, precise emissions standards for the equipment you use, or really detailed safety protocols for things like working at height.
Okay.
So this hierarchy means that even if everyone on the project team agrees to something in their contract, say they agree to cut a corner on an environmental requirement to save money.
Right.
If that agreement conflicts with a statute or a regulation, maybe a local zoning rule or a federal environmental law, the law of the land, the statute or regulation will always override that contract.
Always. No exceptions.
Yeah. No exceptions. That's why compliance isn't just, a good idea or a best practice. It's absolutely non-negotiable. It's a prerequisite, and it affects everything from design choices to how you source materials.
Makes total sense. It's like the operating system. You can't just ignore it.
Exactly.
But this whole idea of structured legal oversight, governance, it feels like it's been around forever. It's not just a modern thing, right? Must have deeper roots.
Oh, you're absolutely right. The historical precedent for this kind of rigorous governance, especially in complex industries, it runs incredibly deep. Centuries deep, actually.
Really? Like what?
Well, think about Jure Agricola's descriptions of 16th century mining operations. He wrote this seminal work, De Re Metallica.
Okay.
And he details the role of this figure called the Burgmeister. This guy was second in power only to the top mining prefect, and he had huge jurisdiction over everyone connected with the mines.
So like a mine boss, but with legal teeth.
Exactly. The Burgmeister wasn't just an administrator, he was basically the on-site legal authority. He'd arbitrate disputes over boundaries, and you can imagine, in mining, boundary disputes were constant and super contentious.
Oh, I bet. Huge money involved.
Huge money. If arbitration didn't work, he would pronounce judgment, but jointly with a panel of jurors. So kind of a rudimentary court system right there.
Wow.
And what's more, there was even an appeal process to the higher mining prefect. So it shows a pretty sophisticated understanding of legal recourse, even back then.
That's amazing for the 16th century.
It is. And his duties were broad. Granting and confirming mining rights, meticulously measuring the mines, fixing those crucial boundaries to stop people encroaching, and critically, ensuring the workings weren't dangerous for the miners.
Safety was key even then.
Absolutely. So this ancient system, it really shows this recognition that even in dangerous, technically complex industries like mining, you needed robust legal and governance structures. It was integral for order, for preventing conflict, for safety, and ultimately just for making the whole enterprise work.
It's a testament, really, to how long we've known we need clear rules for big, risky undertakings.
Exactly right. For centuries.
So fast forward from medieval mines to today's massive, multi-billion-dollar construction projects. That fundamental need for oversight, it obviously persists. How does that translate into modern project governance structures? Who keeps these huge projects aligned with the sort of bigger picture?
Well, in modern terms, project governance functions are absolutely critical. They usually involve specific individuals or groups like a steering committee, maybe who act as the project's sort of institutional compass.
The compass, okay.
Yeah, these are the folks responsible for approving the big recommendations that come from the project team. They provide crucial support, resources. They meticulously monitor progress to make sure the desired outcomes are actually being met.
Right.
And they maintain these continuous, transparent links between the boots-on-the-ground project teams and the broader strategic or business objectives of the whole organization.
Because those objectives can change, right?
Exactly. As the PMBOK guide points out, those strategic goals aren't static. They often evolve, especially over the course of a long project. So this governance function, it ensures that ongoing alignment, it ensures compliance with the bigger mission, and it helps the project adapt throughout its entire life cycle. It's basically a sophisticated system of checks and balances.
Keeps it from going off the rails.
Precisely. Stops projects veering off course from the organizational vision, makes sure the work always adds strategic value, #B, the project environment, and strategic objectives.
Yeah, projects definitely don't exist in a bubble, do they? They're constantly getting buffeted by stuff happening around them. What does the Project Management Institute say about this whole project environment and how it affects things?
Right. The PMBOK guide really emphasizes this. Projects exist and operate within these incredibly complex internal and external environments. And they're anything but static.
Okay, so internal, like company culture.
Exactly. Internal could be the organization's unique culture, the availability of specific internal resources, existing IT systems, the skills of its workforce, things like that.
And external.
External is the much broader landscape. We're talking fluctuating market conditions, shifting government regulations, changes in social expectations like, the growing demand for sustainability, and rapid technological advancements. Think AI, advanced robotics starting to creep into construction now.
Huge changes there.
Huge. And these influences can have varying degrees of impact on how value gets delivered. Sometimes they're really favorable, maybe a sudden boom in demand for the type of building you're constructing.
Makes your project look great.
Exactly. Or they can be distinctly unfavorable new environmental regs that suddenly add significant cost or cause delays. Or sometimes they might just be neutral.
So you have to understand that whole context.
Absolutely crucial.
Yeah.
It's the key to anticipating and effectively managing risks. It ensures the project stays viable, stays adaptable, and keeps delivering its intended value over its whole life.
Sounds like a constant juggling act for management then. It's not just deciding what to build, but also sort of where to place their bets, where to take calculated risks.
Precisely. Peter Drucker, the management guru,
Ah, yes,
he
right.
put it so well. Management is continually facing decisions on where to take risks. And it's not about following some simple formula. It's about making these inherently risky entrepreneurial choices. You're balancing immediate result against the long-range growth and sustainability of the whole organization.
Like choosing market share over short-term profit.
Exactly that kind of thing. A company might consciously prioritize rapid market expansion, even if it means accepting a lower short-term ROI because they think the long-term strategic gain is bigger. Or maybe they favor investing heavily in manufacturing productivity, perhaps putting less into cutting-edge new product design for a while.
Tough calls.
Very tough calls. And understanding the full legal, commercial, and ethical implications is paramount. A choice that maybe cuts corners for immediate results could lead to unforeseen legal liabilities down the road, regulatory fines, massive reputational damage.
Right, wiping out any initial gain.
Completely undermining it. It really requires foresight and a deep understanding of potential consequences.
So, given all these pressures, internal, external balancing objectives, does that mean every project just uses the same management approach? Like a one-size-fits-all? Or can you tailor the style?
Oh, there's definitely room to tailor it. In fact, it's not just room, it's often essential for success. The choice of project approach, like, say, a predictive method, often called waterfall.
Right, the traditional plan everything up front model.
Yeah. Versus an adaptive or agile method,
Hmm.
that choice is heavily influenced by key factors like how stable the project's scope is and how easily changes can actually be incorporated.
Can you give an example?
Sure. Think about building a massive bridge. Super precise engineering. Changes are incredibly costly and difficult once you start pouring concrete, right?
Absolutely.
So a predictive approach makes sense there. Detailed upfront planning, strict adherence to the baseline plan. You want to lock down that design early.
Okay.
But now contrast that with, say, a project for a cutting-edge smart city development. You're integrating evolving software, IoT devices, user needs might change, tech capabilities might change.
Right, much more dynamic.
Exactly. So there, an adaptive approach makes far more sense. It allows for flexibility, iterative development, continuous feedback loops. It kind of embraces change rather than fighting it.
So you choose the approach based on the project's nature.
Precisely. And the PMBOK guide also notes that organizational guidelines usually govern the bounds of this tailoring. So while flexibility is encouraged, it still operates within established boundaries, linking back to that higher level governance and strategic alignment. It's about being pragmatic, choosing the right tool for the job, but within a defined framework.
Okay, here's where it gets really, really interesting, I think. The contract itself. Because it's so much more than just paperwork, isn't it? It's literally the blueprint for how everyone interacts. It defines the terms for success or, potentially for conflict. This is the absolute bedrock.
It absolutely is. And if we connect this to that bigger picture we were talking about, the type of contract you choose fundamentally shifts risk and responsibility across the entire project. Hugely shifts it.
Okay.
So selecting the right contract type becomes this critical strategic decision for everyone involved: owners, contractors, designers. Choosing the wrong one can expose parties to immense unforeseen liabilities and really impact the outcome. It's about designing a partnership that actually fits the project's specific complexities and its risk profile. ###A. Understanding contract types and procurement approaches.
Right. So let's dig into some of these different types. There's one that seems to have gained a lot of traction, especially for complex projects: construction management at risk. What exactly is that, and why is it so popular now?
Yeah, CM at risk, or CMAR, has definitely seen a surge, particularly in Europe and for larger, more intricate projects. What makes it distinct, and folks like Halpin, Senior, and Kiebert explain this well, is that the CM firm essentially takes on the same level of risk for completing the project as a traditional general contractor would in the old design bid-build model.
Okay, so they're on the hook for completion.
They are. In this setup, the CM at-risk firm actually signs all the individual contracts for the construction phase. They manage and coordinate all the subcontractors, the trades, while the owner typically keeps responsibility for the design and the pre-construction phases.
So it's different from just hiring the lowest bidder after the design is done.
Very different. A key differentiator from that traditional competitive low bidding is that the selection criteria for a CM at risk aren't just about the lowest total construction cost. Owners often look at the CM's expertise, their track record, and crucially, their ability to provide valuable pre-construction services during the design phase.
Like what kind of services?
Things like really detailed cost analysis as the design develops, constructability reviews, figuring out if the design can actually be built efficiently and cost-effectively.
That sounds useful.
Immensely useful. Also, value engineering, optimizing costs without sacrificing quality or function, and comprehensive project scheduling. And here's the kicker. The CM at risk typically provides a guaranteed maximum price, a GMP, usually quite early in the design process.
A GMP, so the owner knows the budget ceiling up front.
Exactly. It offers the owner a high degree of cost certainty. They know the project won't go over a certain budget, and often any savings below the GMP are shared between the owner and the CM. It really fosters a more collaborative, value-driven approach. You're leveraging the contractor's expertise much earlier in the game.
Yeah, that makes a lot of sense. It's a big shift from that old mindset of just find the cheapest guy. It sounds like there's a growing feeling that the lowest price doesn't always equal the best result.
Precisely. You hit on a crucial point there. While competitive low bidding awarding purely based on the lowest price, it's still popular, especially in the public sector, often due to regulations.
Right. Got to spend taxpayer money carefully.
Supposedly. But the best value approach is definitely gaining traction, even there. Barbara Jackson highlights this shift. It's an acknowledgement of a hard-won truth in the industry. The lowest initial price doesn't always guarantee the best overall outcome.
Because a low bid could hide problems.
Exactly. A seemingly low bid might mean corners are being cut, less experienced labor is being used, maybe inferior materials, all leading to costly problems down the road. The best value approach lets owners consider a wider range of factors.
Beyond just the price tag.
Way beyond. Things like the contractor's reputation, their experience on similar projects, how reliable their proposed schedule looks, the quality of their team, maybe innovative approaches they suggest. It's a much more holistic view of value. It recognizes that investing may be a bit more upfront for proven quality, reliability, and expertise can actually lead to significant savings and a better final product in the long run. It's a more sophisticated understanding of true project value. Hashtag BP.
Defining the scope and handling changes.
Okay, so whether it's CM, at risk, or traditional design bid build, one thing seems absolutely vital in any contract: defining the scope of work. Crystal clear. But projects, they change, right? Things happen. What happens when that scope isn't stable or when it inevitably needs to shift?
Yeah, the nature of the scope, what you're actually building, is absolutely critical. If that scope is incredibly stable, very unlikely to change. Imagine building, say, a standardized warehouse model you've built dozens of times.
Okay, predictable. Very predictable. Then a predictive approach to project management. Detailed upfront planning, strict adherence to schedule, minimal changes. That's usually most effective. You map it out, you build it.
But that's not always reality, is it?
Not often for complex projects. The reality for many unique or innovative construction jobs is that changes aren't just possible, they're often expected. If you're building some groundbreaking architectural statement or integrating brand new technologies,
The design might evolve.
exactly. It might evolve as new insights emerge or you discover unexpected challenges. In those cases, an adaptive approach, allowing for more flexibility, iterative design, continuous adjustment, that becomes far more effective. It kind of embraces that evolving understanding.
So it depends on the project's changeability.
And also how difficult changes are to actually incorporate. If changes are inherently hard and costly, like, say, modifying a deep foundation once it's poured, then a predictive approach, aiming to lock down the scope early and thoroughly, is still preferred. The key takeaway is that the contract must clearly state which approach is being taken, how scope will be managed, and precisely how it's going to handle those inevitable curveballs and changing requirements. Misjudging this can have, well, catastrophic consequences.
And when those changes do pop up, I assume it's not just a casual chat, hey, let's change this. There's a formal process, right, for documenting it.
Oh, absolutely. And it's called a change order. And it is utterly vital for project success and for legal protection. As Edward Allen and Rob Thalen explain it, an official change order is a formal, legally binding agreement. It modifies, adds to, or subtracts from work already under contract.
Okay, legally binding.
Critically. And the document doesn't just describe the change in the work, it also must include a provision for adjusting the contract price and the schedule accordingly.
So cost and time implications are spelled out.
They have to be. For example, if the owner decides midway through to upgrade all the interior finishes, the change order details the new materials, the extra cost, and any needed extension to the timeline. Without clear, documented change orders, projects just spiral into chaos. Ambiguous verbal agreements, undocumented scope creep. They lead to massive cost overruns, crippling delays, and eventually bitter fights over who's responsible for what.
So managing these properly isn't just good practice.
It's essential. Essential for clarity, control, and legal standing.
Okay, so poorly managed changes can cause huge problems, not just schedule-wise, but financially too. Can you give us some sort of vivid examples, real-world risks when changes aren't handled meticulously?
Oh, definitely. Sidney Levy in his work points out several really common and costly pitfalls that stem directly from poor change management or just not paying attention to the contract details.
Like what?
Okay, first, costly resubmittals. Contracts often say contractors have to submit complete and accurate submittal data. Think shop drawings, material samples, product specs right the first time.
Get it right the first time.
Yeah. If a submittal needs resubmission because it's incomplete or wrong, maybe only one additional review is covered by the owner's cost. Any more after that, usually at the contractor's expense.
Ouch. That could add up fast.
It adds up incredibly fast.
Yeah.
Imagine the engineering team having to revise drawings multiple times, or a supplier having to resend samples. Each instance costs the contractor time, money, potentially delays the project, and just eats away at their profit.
Okay, what else?
Then there's the really severe consequence of schedule delays and unpaid overtime. If a contractor falls behind schedule, they typically have to tell the owner in writing what they propose to do to fix it.
Right, a recovery plan.
Exactly. But in severe cases where the delay is clearly the contractor's fault, the owner might have the contractual right to demand the contractor work extra hours, Saturdays, Sundays, holidays, at no extra cost to the owner, just to get the project back on track.
Wow, that's harsh. Working for free, essentially.
It's a very severe financial squeeze. It's a powerful contractual tool owners have, and it really underscores why accurate scheduling and execution from day one are so critical.
Okay, that's a big one.
Any others? Another incredibly common and kind of sneaky pitfall is the misuse of unapproved drawings. Levy describes this scenario. Maybe unapproved shop drawings get accidentally left out on a plan table in the site office.
Oh.
Yeah, an inquiring subcontractor, maybe they're in a rush, maybe no one's around to ask. They might mistakenly grab this unapproved drawing and start working based on it.
And build something wrong.
Exactly. Imagine installing a whole section of ductwork based on an outdated layout, only to find later it clashes directly with newly routed electrical conduit. This creates incredibly costly rework, throws the schedule completely off, and inevitably leads to heated arguments about who pays for the mistake and the fix.
Nightmare scenario.
It's total nightmare. And one more, a bit more nuanced. Method statements and contractual obligations. Owners often require contractors to submit method statements, these detailed documents outlining how they'll perform a specific task, often focus heavily on health and safety.
Okay. Seems sensible.
It is. But here's the critical distinction Julian Bailey points out. These method statements don't always legally form part of the contract itself.
Wait, really? Even if the owner required them?
Yes, and this is crucial for liability. It means that if a contractor fails to strictly follow its own method statement, it might not necessarily be a direct breach of contract because the method statement wasn't a contractually binding document in the first place.
Huh. That's a subtle but huge difference.
It's a very nuanced area of contract interpretation and potential liability. Assumptions about a document's legal standing can lead to major headaches and costly legal fights if something goes wrong. ####C, performance measurement and baselines.
Okay, with all these moving parts, potential delays, meticulous change management, how do project managers actually keep track of everything? How do they know if they're on track before small problems blow up into major crises?
It really requires constant vigilance, and it relies heavily on rigorous performance measurement against established baselines.
Baselines, like the original plan.
Exactly. Most projects meticulously track at least two critical baselines, cost and schedule. You're constantly measuring actual performance against these planned targets, comparing actual money spent to the planned budget, actual start and finish dates to the planned milestones.
Right.
Any deviations, even seemingly minor ones, or maybe deviations on tasks that aren't even on the critical path, they're immediate indicators that the project isn't performing according to plan.
Like warning lights on a dashboard.
That's a perfect analogy. If your engine temperature starts creeping up, even if you're still driving fine, you know you've got an issue needing attention before it becomes a total breakdown. These deviations are crucial early warning signals.
So it's more than just looking at a simple Gantt chart then. I assume there are more sophisticated tools for this, ways to get a deeper dive into project health, maybe forecast where things are heading.
Oh, absolutely. One of the most powerful tool sets comes from Earned Value Management, or EVM. It gives you a quantitative way to assess performance and progress.
Okay, EVM. How does that work?
Well, it has measures like variance at completion, BAC. This forecasts whether the project is likely to end up with a budget deficit or a surplus. It's basically the difference between your total planned budget and what you now estimate the project will actually cost when it's all done.
So it tells you if you're heading for trouble financially.
Exactly. Think of your personal budget. VAC is like forecasting if you'll have money left at the end of a month or be in debt based on your current spending patterns.
Got it. What else?
Then there's the Two Complete Performance Index, TCPI. This one's even more proactive. It estimates the cost performance you need to achieve on the remaining work to hit a specific target, usually the original budget.
So it tells you how efficient you need to be from now on.
Precisely. It asks, given how much work is left and how much budget I have remaining, how efficiently do I have to perform from this point forward to hit my target? If your TCPI is, say, 1.2, it means you need to get 20% more work done for every dollar spent on the remaining tasks just to finish on budget.
Wow, that puts the pressure on.
It does. But these aren't just backward-looking measures. They give you critical, forward-looking insights. They allow for proactive adjustments rather than just reactive firefighting when it's too late.
Are there other analytical methods too?
Yeah, another really useful one is regression analysis. This is a statistical technique. It examines input variables in relation to their output results to develop a mathematical relationship.
Okay, like finding correlations.
Exactly. For instance, you might analyze how factors like material delivery times, crew size, and maybe even weather conditions, those are your input variables, correlate with the daily rate of concrete poured, that's your output result. Once you establish that relationship mathematically, you can then use it to infer and predict future performance with some degree of confidence. It helps project managers spot potential problems much earlier, often before they become critical and costly, allowing for predictive intervention.
All right, so we've got the legal framework, the contracts, ways to measure performance.
Yeah.
But what happens when, despite all the best plans and intentions, things still go wrong? Who's actually on the hook when mistakes happen or unexpected events occur? Because it feels like risk is just everywhere in construction.
It absolutely is. And this brings up that crucial question. How risk isn't just reacted to after something bad happens, but how it's proactively assessed, mitigated, and strategically allocated among all the project parties right from the very beginning.
So building in resilience from the start.
Exactly. It's about foresight. Understanding you can't eliminate all risk, but you can certainly manage its potential impact. Hashtag tag, 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 tag A, the challenge of design coordination and rework.
Speaking of things going wrong, I can just imagine how incomplete or uncoordinated designs must cause massive, expensive headaches on site. How do modern tools help with that? Because the old ways seem almost designed to cause problems.
Oh, incomplete design coordination is notorious. It's an incredibly costly source of problems in traditional construction. Conflicts between different systems like, the HVAC ductwork needs to run through the exact same space as a main structural beam.
Yeah.
Or plumbing pipes clashing with electrical conduits. These things are often only discovered during the actual installation phase, on site, when it's hardest to fix.
Leading to rework.
Massive, costly rework, significant delays, immense frustration for everyone involved, and it inevitably hits the fabricators, the installers, the whole schedule, regardless of who technically bears the legal or financial liability in the end.
So how do we avoid that?
This is exactly where modern tools like building information modeling, BIM, have become such a game changer.
I heard a lot about that.
Specifically, advanced software like Autodesk Navisworks Manage. It can integrate 3D models from all the different design platforms, architectural, structural, mechanical, electrical, plumbing into one single comprehensive virtual environment.
Like a digital twin of the building.
Essentially, yes. And then it automatically identifies physical clashes before construction even starts. Imagine being able to virtually walk through the building months before ground is broken and see all these potential conflicts highlighted in red.
That sounds incredibly powerful.
It is. It significantly improves design coordination because conflicts get resolved in the virtual space where changes are cheap and easy instead of on the construction site where they're incredibly expensive and disruptive. This directly contributes to what we call leaner construction, making work predictable, uninterrupted, efficient. By reducing that variation and improving efficiency through digital means, BIM really helps avoid rework and manage complex designs effectively, hashtag tag 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 B, proactive risk management, and contractual safeguards.
Okay, so anticipating problems virtually is key. But beyond design clashes, how does the industry systematically tackle the million other risks that can pop up on a project?
Well, every serious construction project, right from the get-go, absolutely must establish a comprehensive design and construction risk management plan.
Not just an afterthought.
Definitely not. It's not just a document you file away, it's a living guide. As the CMAA Standards of Practice outline, this plan should clearly define risk terminology, establish the organization's policies on risk appetite, and detail specific methods for identifying and mitigating risks.
So everyone's on the same page about risk.
Exactly. Its purpose goes beyond just documentation. It's designed to foster a team-wide understanding and commitment to managing risk. It guides how the team approaches potential issues, allowing them to proactively address them through strategies like risk avoidance, mitigation, transferring risk like through insurance, or maybe just consciously accepting a risk.
Rather than just being caught off guard.
Right. A good plan might identify potential supply chain disruptions and maybe pre-negotiate alternative suppliers just in case. Or it might anticipate possible regulatory changes and build some contingency time into the schedule. It's about proactive preparation.
And what about one of the scariest risks for owners? Financial issues with subcontractors. That seems like a minefield.
It's an incredibly critical area, absolutely, and one that requires immense vigilance. A really significant financial risk involves those lower-tier subcontractors, the subs working for your main subs.
Okay, the subs of subs.
Right. For instance, say your prime subcontractor for all the plumbing work gets paid by the owner, but then for whatever reason, maybe they have cash flow problems, they fail to pay their sub-tier contractors, the company that actually fabricated the pipes or the crew that installed the fixtures.
Okay.
Those unpaid lower-tier subs have a very powerful legal recourse. As Sidney Levy explains, they can place a lien on the entire job.
A lien? That sounds bad. What is it exactly?
A lien is essentially a legal claim or right against a property until a debt related to that property is paid. So in this scenario, the owner's property, their brand new building, can effectively be held hostage or legally encumbered by this claim, even though the owner already paid the prime contractor for that work.
Wow. So the owner could end up paying twice? Or lose the building?
Not lose the building necessarily, but imagine trying to sell or refinance a building with a lien clouding the title. It's a massive problem. So to protect the owner from this kind of potentially devastating financial mess, project managers have to be incredibly diligent.
How?
By diligently obtaining lien waivers from all levels of subcontractors and suppliers.
Lien waivers.
A lien waiver is a formal, legally binding document. The subcontractor signs it, confirming they've been paid for their work up to a certain point, and in exchange, they waive their right to place a lien on the property for that work. It's a fundamental contractual safeguard. It's that vital paper trail that shields the owner from having their property held hostage by disputes happening further down the payment chain. ####C. The human element in risk and informal practices.
It sounds like all these legal rules, plans, contracts,
Mm-hmm.
they try to control every possible variable. But at the end of the day, people are involved. How does that inherent human element factor into risk and maybe even into informal practices that kind of bypass all those formal rules?
That's such an important question. How do we navigate inherent human tendencies within these rigid legal frameworks, especially when those tendencies might push people against the rules? Rasmussen's model offers a really fascinating perspective on this. He talks about the migration of work towards a loss of control.
Migration towards loss of control. What does that mean?
He highlights that both individual tendencies, like a worker taking a shortcut they think is safe to save time, and organizational pressures like really aggressive deadlines or maybe limited resources, can push people to work in risky circumstances. They end up operating right at the edge of control.
Okay.
Now, instead of just trying to enforce rules more strictly with a heavy hand, which often backfires because people just find new ways around them,
Right.
Rasmussen suggests that empowering workers, helping them develop and apply their own judgment in these dynamic, often uncertain situations, can actually be more successful for safety.
So trust their judgment more.
To an extent, yes. It's about recognizing that people will adapt their work practices to meet demands. It's far better to equip them with the judgment, the training, the support to adapt safely and intelligently within the system, rather than just assuming they'll always stay inside rigidly defined safe zones when they're facing real-world pressures. It acknowledges human ingenuity and pragmatism, but aims to guide it safely.
That makes a lot of sense, acknowledging reality. But what about when that informal stuff completely bypasses the legal framework, like unpermitted work, what some people call cob work? That seems like a huge hidden risk out there.
It is indeed a pervasive and often hidden challenge, and it creates immense, unaccounted for risk. Stuart Brand, in his fantastic book, How Buildings Learn, notes that a really significant percentage of remodeling work, he estimates maybe 10–15% of all remodeling.
Oh, wow, that high.
That high is undertaken without any formal permits or inspections. People employ all sorts of tactics to hide this new work from authorities, staining new lumber so it looks old, doing work in tiny stages to avoid detection, maybe cleverly covering up newly installed wiring or plumbing before anyone official sees it.
Sneaky.
Very sneaky. And while this allows for this constant, often pragmatic adaptation of buildings by their occupants, it frequently leads to what's often called cob work, basically. Shoddy prior work done on the slide, definitely not up to code.
Like dangerous wiring.
Exactly. Imagine an unqualified handyman installing hazardous, incorrectly wired electrical circuits or maybe leaky plumbing pipes hidden behind brand new drywall, completely out of sight of any inspector. This can result in incredibly dangerous, even life-threatening conditions that might remain undetected for years.
Until something goes terribly wrong.
Precisely. When this cob work is eventually discovered, perhaps during a later permitted renovation or worse, when a problem manifests as a catastrophic failure like a fire or major leak, it requires extensive, incredibly costly remediation. It starkly highlights this huge gap between the formal legal requirements designed for safety and quality and the informal, often budget-driven or convenience-driven practices happening on the ground. It creates these hidden risks that are almost impossible to allocate or insure against, posing a significant threat to building safety and long-term value.
Okay, so we've covered the legal foundations, the contracts, the risks, both formal and informal. But look, no matter how meticulously you plan, how carefully you draft contracts, or how diligently you manage risks, disagreements just seem inevitable in complex projects. So when conflicts do happen, as they always seem to do, how do we resolve them without completely derailing the whole project?
Right, and what's fascinating here is how this core challenge resolving conflict remains absolutely central to successful project delivery, regardless of the era. The specific power dynamics, the legal processes, they've certainly evolved over centuries, but that fundamental need for structured ways to handle disputes, that's been a constant in human enterprise. Hashtag tag, 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 come here. Historical mechanisms of resolution.
Let's loop back to that Bergmeister example in 16th century mining. You mentioned they played a big role in resolving disputes. Can you flesh that out a bit more? What kinds of conflicts did they handle? How did their system actually work?
Absolutely. The Bergmeister really was the central legal and judicial figure on site, demonstrating a remarkably sophisticated early system. They didn't just manage operations, they had direct jurisdiction over everyone involved, with the mines acting as both arbiter and judge.
So what disputes came up?
All sorts, and often high-stakes ones. Imagine those boundary disputes between adjacent mine owners we talked about. A tiny shift in a boundary line could mean losing access to a rich vein of ore, vast mineral wealth.
Right, huge implications.
Huge. The Bergmeister would first try to arbitrate these, using their expert knowledge of mining rights and land measurement. If that failed, crucially, they would then pronounce judgment, but jointly with a panel of jurors bringing a community element into it, much like broader legal practices of the time.
A jury trial, essentially.
In a way, yes. And importantly, there was that appeal process to the higher mining prefect, which added structure and legitimacy. It ensured some level of oversight and fairness.
So even back then, a structured system.
Definitely. This historical example vividly shows that even in these early industrial societies, the need for clear, impartial conflict resolution was deeply understood as vital. It wasn't just about settling personal squabbles, it was about maintaining order, ensuring fair access to resources, and critically, maintaining safety and productivity in what was an inherently dangerous and economically vital environment. It shows this deep human need to establish clear rules and clear mechanisms for when those rules get challenged. Hashtag tag 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 B, real-world legal battles and public works.
That's a great look at the past. Let's bring it forward, though, to more recent history, where legal battles played out on a huge scale, really shaping our modern cities. Robert Moses in New York, hugely influential, often controversial. He certainly left his mark, but not always without a massive fight.
Oh, absolutely. Robert Moses was a titan of 20th century urban planning in New York, responsible for an incredible amount of infrastructure, bridges, highways, parks. but he frequently faced fierce opposition to his ambitious, often ruthless plans.
How did he push things through?
He was a master, really, at leveraging his immense political power, his public popularity, and just his sheer force of will. A key tactic he often used, as Robert Caro details so brilliantly in The Power Broker, was to use administrative decisions to bypass public hearings and direct protest.
Sneaky again. How did that work?
It allowed him to fast-track his agenda, often catching opponents off guard by reframing really contentious issues as just simple bureaucratic procedures.
Can you give us a concrete example? Maybe a dramatic one.
A prime example, and a really dramatic one, involves his efforts to demolish the historic aquarium and the venerable Fort Clinton down at Battery Park, all to make way for a new approach ramp for the Brooklyn Battery Tunnel.
Okay. Demolishing historic landmarks.
Yeah.
Bound to cause opposition.
Fierce opposition. It was a beloved public landmark. Conservationists, reformers, they were up in arms. But Moses, well, he wasn't one to back down. Instead of seeking direct approval for demolition, which would have absolutely triggered a firestorm of public hearings and protests he couldn't easily control, he used this clever, audacious tactic. He simply announced the closure of the sites for public safety reasons. Then he sidestepped the whole demolition controversy by requesting a mere $20,000 appropriation, not to tear down the fort, but just for moving the fish from the aquarium up to the Bronx Zoo.
Moving the fish. That's it.
That was the request put before the Board of Estimate. He presented them with this limited, almost guilt-tripping choice: approve the funds to move the fish, or risk them being dumped in the sea because the park was closing anyway. He framed it as a simple administrative need, completely sidestepping the real, highly contentious issue of destroying a historic fort.
That is incredibly manipulative. So how did the opponents fight back against that kind of power play?
Well, it led to a truly protracted and dramatic legal battle. The opponents, notably led by this incredibly tenacious figure, George McCanney, eventually managed to secure an injunction against the demolition.
Okay, so they stopped him.
Temporarily. But Robert Caro recounts this shocking detail that really speaks to Moses's ruthless character. In the brief, crucial window before the injunction could be officially served, Moses reportedly ordered the historic, centuries-old great doors of Fort Clinton to be burned.
No, he burned the doors.
That's the account, an act of almost preemptive destruction. It shows his aggressive, take-no-prisoners approach.
Unbelievable. So what happened then? Did he win?
Well, McCanney and his allies were incredibly persistent. They engaged in almost a decade of sustained legal maneuvering, public advocacy, delay tactics. They fought in the courts, in the press, in the halls of power, and ultimately their extraordinary efforts paid off. Congress eventually passed a bill in 1950, officially designating Fort Clinton as a National Historic Monument. And crucially, they allocated federal funds for its restoration, including replacing those very doors Moses had apparently destroyed.
Wow. So persistence paid off.
It did. This whole saga powerfully illustrates the enduring power of sustained legal and political pressure to preserve historical structures, even against immensely powerful development interests. It's a testament to how legal frameworks can be both exploited by the powerful, but also ultimately used as a shield against unchecked power.
It's incredible how those fights shape not just the physical city, but legal precedents too.
Mm-hmm.
And it also makes me think about those carefully worded disclaimers you see everywhere now. Even in textbooks, professional guides, everyone seems to be trying to limit their liability.
Absolutely. That Moses saga, the constant legal battles, it ties directly into this pervasive, constant consideration of accountability and liability in our modern world. You look at many professional guides, textbooks, even ones intended to provide essential knowledge for construction managers. They almost always contain these very explicit limit of liability disclaimer of warranty clauses.
A fine print.
Exactly. As Barbara Jackson highlights, they typically state that the publishers, the authors, they make no warranties about the accuracy or completeness of the content, and they specifically disclaim liability for any commercial damages or losses people might incur if they rely on that information.
Covering their backsides.
Completely. And it's not just an oversight, it's a crucial legal safeguard. It underscores the meticulous legal language used across the entire industry to manage expectations and, more importantly, to define and try to avoid liability. It reflects the high-stakes nature of construction, where even a seemingly minor error in a guideline or a misinterpretation of a contract clause can lead to immense financial or safety consequences. This practice of carefully defining liability is a constant consideration in virtually all construction-related documentation, from contracts to guidance manuals. It reflects an industry where the stakes are perpetually high and the need for clear boundaries is paramount.
Okay, so it's clear it's not just about the big legal agreements and contract types. Every single building, every project also has to conform to this whole other universe of established rules and standards for how to actually build them, down to the smallest detail, right? To ensure safety, structural integrity, performance. This is where the law really meets engineering on the ground.
Absolutely. And if we connect this to the bigger picture, these incredibly detailed codes and standards, they aren't just arbitrary rules dreamed up by some committee somewhere.
Yeah.
They are distilled knowledge, often hard-won knowledge from past failures, devastating fires, structural collapses, lessons learned from earthquakes or hurricanes. They represent this collective wisdom on how to build safely and effectively. And they're constantly evolving with every new insight, every new material, every new technology. They're constantly working to protect us all. Hashtag ACO. Building codes as a legal framework for safety and design.
So when we talk about the real nitty-gritty of how a building is physically put together, the International Building Code, the IBC, seems like the central authority that most places adopt. What are some of its core classifications and requirements, especially when it comes to safety?
Yeah, the IBC is definitely a foundational legal framework, especially for life safety and structural integrity. Francis D.K. Ching, who's a master at illustrating these concepts, explains how the IBC meticulously classifies buildings into 5 broad categories, Type I through Type V.
Type I to V, what's the difference?
It's based fundamentally on the fire resistance capabilities of their main structural materials. Type I construction, for example, is the most fire resistive. Think non-combustible materials like reinforced concrete, protected steel, designed to withstand fire for extended periods.
Okay, the safest in a fire.
Generally, yes. Type V at the other end is the least fire resistive. That's typically used for light frame wood construction, like in smaller residential buildings.
Okay.
And this classification is absolutely crucial because it dictates the required level of passive fire protection. That's the fire resistance built right into the building's structure, the walls, floors, roof system. It also impacts the balance with active fire suppression systems, like automatic sprinklers.
So a less fire-resistant building type might need more sprinklers.
Exactly. You might need a more extensive active sprinkler system to compensate and achieve the overall required level of safety. It's all about this layered, balanced approach to fire safety.
And the code gets really specific about these safety features, doesn't it? It's not just broad category.
Incredibly specific. The level of detail is staggering, frankly, because lives depend on it. The IBC includes highly specific prescriptive requirements for ensuring life safety in an emergency. For instance,
Like what?
okay, firewalls and party walls. Firewalls are designed to compartmentalize a building, right? Create these fire-resistive barriers to stop fire spreading. The code mandates they have to be continuous horizontally, and they have to extend beyond the exterior walls, often right up through the roof, to prevent fire just flanking around the barrier.
Makes sense. What about party walls?
Party walls, the ones right on the lot line between 2 adjacent buildings, have an even stricter requirement. They must be built as firewalls without any openings. No doors, no windows, no duct penetrations, nothing. Effectively creating 2 completely separate, fire-isolated buildings, critical for stopping fires jumping between properties.
What else?
Egress and illumination. Clear, safe pathways out of a building in an emergency are paramount. The code specifies precise illumination levels. Exit ways and stairs typically need 10-foot candles when in use, which is roughly, a brightly lit office space, ensuring clear visibility even in a panic. Safe dispersal areas outside need at least 1-foot candle, and beyond general egress vary. And exit access stair enclosures. Generally, stairways have to be enclosed in fire-rated walls to stop smoke and flames spreading between floors. But there are specific exceptions, like stairways connecting only 2 adjacent stories might be exempt, or stairs within a single apartment connecting 4 or fewer stories. Or sometimes, if you have an automatic sprinkler system, plus a draft curtain, plus closely spaced sprinklers right at the opening, that might protect the opening sufficiently without a full enclosure. These details are incredibly critical, balancing practical design with uncompromising safety.
These rules sound incredibly detailed, down to the light levels. Are there also limits on just how big or tall a building can be, depending on how it's built and used?
Yes, absolutely. The IBC doesn't just say how to build, it also puts limits on what you can build. There are tables right in the code that specify allowable building heights measured in stories above the ground plane and allowable areas for each floor.
And these limits vary.
They vary significantly based on that construction type I to V. The occupancy classification, like is a residential, assembly, business, storage, and a really crucial factor, whether automatic sprinkler systems are installed. Sprinklers often allow you to build higher and larger because of their enhanced fire suppression. This whole interlocking system of classifications and requirements ensures buildings are built to appropriate safety standards for their specific use and scale. It provides a consistent baseline for public safety everywhere the code is adopted. ###B, material standards, quality, and sustainability.
Okay, so beyond the overall structure and fire safety, what about the actual materials themselves? The concrete, the steel, the wood. How are those regulated to make sure they have the quality, the strength, the durability needed? It can't just be guesswork.
Definitely not guesswork. It's a highly structured and continuously evolving science. The building codes rely heavily on structural material standards that are developed by specialized institutions and organizations.
Look.
Think of groups like the American Concrete Institute, ACI for concrete, or the American Institute of Steel Construction, AISC for steel. These groups bring together experts, engineers, material scientists, manufacturers, designers, testing agencies.
The specialists.
Exactly. And they establish comprehensive criteria for everything: material strength, how to do the design calculations, rigorous testing protocols, robust quality assurance measures for specific materials.
And these standards change over time.
Continuously. They're constantly updated to incorporate new knowledge. Maybe breakthroughs in material science, improvements in design methods, or critical analysis of how materials performed under real-world conditions. High winds, earthquakes, fire. This continuous learning and adaptation is vital to making sure our buildings aren't just structurally sound today, but also resilient against evolving threats and new challenges.
That level of detail even extends down to something as fundamental as a piece of wood, right?
Right.
How do we know if that specific 2x4 is strong enough for, say, a floor joist?
Absolutely. Even with wood, there's a rigorous system. We rely on wood grading and allowable stresses. Lumber gets graded based on visible characteristics, its growth rate, the presence, size, location of knots, the slope of the grade.
Things you can see.
Things you can see. This stress grading process is critical because it establishes reliable, allowable stress values for structural use. And these values aren't arbitrary. They're meticulously adjusted for the normal variability you find in a natural material like wood, for how long a load will be applied, like a short-term wind gust versus a permanent roof load, the moisture content of the wood, and crucially, a built-in safety factor.
So you know what it can handle.
Exactly. For example, light framing lumber for houses is often ordered as #2 and better. That signifies a specific quality standard, ensuring it can reliably bear certain calculated loads. This whole process ensures that when wood is used structurally, its performance can be predicted, relied upon, and safely integrated into the design.
And today, it's not just about the building standing up. We're also really focused on environmental performance, healthy indoor spaces. What do the codes say about controlling moisture and hitting energy efficiency targets? That seems critical now.
Increasingly critical, yes. It reflects a much deeper understanding of building science and sustainability. Joseph Ilstabarek, a well-known building scientist, highlights how codes now specify pretty rigorous requirements for controlling moisture and achieving energy performance.
Like what?
For instance, kitchen range hoods are now often mandated to be ducted directly to the outside, not just recirculating the air to get rid of moisture and pollutants effectively. Mechanical ventilation is often needed for interior moisture control year-round, preventing humidity buildup that leads to mold and poor indoor air quality.
What about insulation in slabs?
Yeah, to boost energy performance and minimize condensation, insulating sheathing is frequently required on roof decks. For concrete slabs on the ground, which are prone to moisture from below, requirements often include subslab drainage with a granular capillary break, basically a layer of gravel to stop moisture, wicking up robust vapor barriers, radon-resistant construction measures in many areas, and perimeter insulation around the edge of the slab in colder climates to stop heat loss. These comprehensive measures aim to create healthier, more energy efficient, and ultimately more durable buildings that perform well over their entire life.
Beyond just the basic code compliance, though, this whole green building movement has really exploded, driven by a desire for even higher performance, right? What are the main frameworks, the rating systems driving this globally?
Yeah, the growth of high-performance green buildings has definitely led to several prominent and influential sustainability and green building rating systems worldwide. We're talking about systems like BREEAM in the UK,
Okay.
LED Leadership in Energy and Environmental Design in the US,
Heard of LID.
and DGNB, the German Sustainable Building Council in Germany. Charles Kiebert explains how these systems provide a comprehensive framework. They define what a green building actually is, and they offer detailed criteria and scoring mechanisms for getting certified at various levels, like certified, silver, gold, platinum.
So they provide a roadmap.
Exactly. The use of checklists within these systems has rapidly increased the adoption of green building practices by giving designers and builders a clear, actionable path. However, Keyword also points out a critical nuance. While these checklists are super useful for broad adoption and setting measurable goals,
There's a but.
there's a but. A deeper understanding of natural systems and ecological design principles is seen as crucial for creating truly exceptional buildings. Buildings that don't just accumulate points on a checklist, but that integrate seamlessly with nature, providing profound environmental and social benefits that go way beyond mere compliance or basic certification. It's about moving from just ticking boxes to genuine ecological integration.
And to achieve that deeper, truly integrated design that these top-tier green buildings aim for, is there a specific design process that's favored? Or maybe even required by the standards?
Yes, absolutely. The integrated design process, or IDP, is a critical component. It's highly emphasized in many green building standards precisely because it's fundamental to hitting those ambitious sustainability goals.
How is IDP different?
Unlike traditional linear design processes where disciplines often work in silos, architect does their bit, then hands off to the engineer, etc.
Right, the old way.
IDP fosters early, continuous, and intense collaboration among all the project stakeholders: architects, engineers, contractors, the owner, maybe even the end users, right from the project's very inception. This collaborative approach allows for holistic problem solving and system optimization you just don't get otherwise.
And it covers more than just design.
Oh yeah. IEDP encompasses not just environmental management during the construction phase itself, making sure the process is green, but also expanded building commissioning. Commissioning now covers far more than just the traditional building services: HVAC, plumbing, electrical. It extends to the building envelope, the walls, roof, windows, structural components, even things like noise isolation. It verifies that all systems are installed right, calibrated correctly, and performing optimally, both individually and as an integrated whole, to meet the building's specified performance goals for energy, comfort, and environmental impact. It's really about designing and building a truly high-performing integrated machine, not just assembling a collection of separate parts.
Okay, so we've journeyed through the legal maze, the bedrock of contracts, the complexities of risk, the precision of codes. But ultimately, it's people who build these things. People navigate the laws, the specs, the challenges, and that human element, the skills, the collaboration, the communication that can be just as strong or just as fragile as any steel beam or concrete pour.
That raises such an important question. How do we actually foster genuinely effective collaboration and clear communication within these often very rigid legal and technical frameworks? How do we build not just impressive structures, but equally impressive, successful teams? Because, let's face it, the most perfectly drafted contract doesn't mean much if the people executing it can't, or maybe won't, work together effectively. #####A, the crucial role of team dynamics and collaboration.
Exactly. So with all these complex moving parts, all these different specialists involved,
Yeah.
how do you actually get these project teams to truly work together? Because collaboration, it doesn't just magically happen, does it?
No, absolutely not. Collaborative behavior, as some really insightful research highlights, is rarely spontaneous. It can, and it really must be, actively fostered, strategically cultivated.
How do you do that?
This is where modern approaches like integrated project delivery, IPD contracts, and lean processes and tools come in. They act as powerful carrots, basically, designed to enhance team members' willingness and ability to collaborate.
Parents, how so?
Well, IPD contracts, for instance, often share risks and rewards among the key project participants. So everyone's financial incentives are aligned towards the common project goals, rather than creating an adversarial environment where everyone's just protecting their own turf.
Ah, shared fate.
Exactly. Lean tools, on the other hand, focus on things like value streams, reducing waste, continuous improvement, which naturally encourage teamwork and communication. It's really about creating an environment where people want to work together, where collaboration is actively supported, encouraged, and even rewarded.
So it's intentional.
Very intentional. It involves motivating, aligning, mentoring the team, using structured practices like purposeful onboarding and offboarding processes. These practices cultivate genuinely high-performing team behaviors because members feel supported, they feel encouraged, and they're often financially rewarded for taking collaborative approaches to solving project challenges. It leads to significantly better outcomes than a purely adversarial, siloed way of working. It's about building a shared purpose that transcends individual interests.
And when it comes to really understanding what the owner actually wants, especially if those goals aren't perfectly clear at the start, or maybe they change along the way, how important is that strong team dynamic in just making sense of it all?
Oh, it's absolutely crucial. And it's where truly effective teams really distinguish themselves. Owner goals, especially for big, complex projects, they can be initially unclear, maybe broadly stated, or they might evolve significantly as the project progresses and new information comes to light.
Right.
An effective team isn't just sitting back passively waiting for instructions. They're skilled at interpreting and translating those owner goals, even the ambiguous ones, into actionable, tangible steps. They proactively engage in dialogue, they ask the probing questions, they use their collective expertise to refine and clarify the owner's vision.
So they help shape the goal too.
In a way, yes, they help clarify it. And in successful case studies of projects using these collaborative methods, the research is striking. 100% of the owners consistently felt their projects met or even exceeded budget and schedule expectations, even if the initial targets themselves shifted during the project.
Wow, 100% satisfaction even with changes.
It's a profound finding. It demonstrates the immense power of strong team understanding, adaptive problem solving, and that collaborative spirit. It allows them to deliver exceptional value and satisfaction even in ambiguous or changing circumstances because they're constantly working to align with the owner's evolving needs, not just slavishly following a static document from month one, hashtag tag 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 DB, the impact of management styles on the job site.
Management style must play a huge role in either fostering or maybe hindering that collaboration. There's that historical management approach often called scientific management or Taylorism. It gets criticized a lot today for being so rigid, so top-down. Can you tell us about that?
Yes, back in the early 20th century, Frederick Winslow Taylor's scientific management philosophy became incredibly influential, especially in manufacturing, but it spread to construction too. As Matthew Crawford critiques it, Taylor's really radical aim was to remove all possible brain work from the shop floor.
Remove the brain work.
Yeah, it meant centralizing all the craft knowledge, the intricate understanding of how things are actually made and done entirely within management. Integral craft activities, things once performed by skilled artisans who understood the whole process. They were broken down into minute, highly detailed, often repetitive instructions for workers.
Why? What was the goal?
The underlying goal was efficiency and control, to make tasks so simple that skilled labor could be replaced by cheaper, unskilled labor. It also reduced the bargaining power of skilled workers. So this approach prioritized management control, rigid standardization, labor cost reduction, way over worker autonomy or holistic understanding of the craft, or even just the intrinsic satisfaction you get from doing skilled work well. It was essentially about making the worker an extension of the machine.
That sounds incredibly dehumanizing and completely counter to what we're talking about now with empowered teams. How do modern lean principles, which are so big in high-performing industries today, directly contrast with that old Taylorist style?
The contrast really couldn't be starker. In sharp opposition to Taylorism's idea of centralizing knowledge and stripping autonomy, modern lean principles advocate for profoundly empowering workers and fostering continuous improvement throughout the whole system.
Wow.
Well, instead of seeing breakdowns or mistakes as failures to be punished, lean encourages learning from breakdowns, seeing them as invaluable opportunities to identify systemic weaknesses and actually improve the processes so they don't happen again.
Okay, learning, not blaming.
Exactly. Lean also champions underloading resources rather than maximizing utilization all the time, which might sound counterintuitive.
Yeah, why underload?
It means not pushing every resource people equipment to an absolute limit constantly. By building in some buffers, you actually increase the reliability of work getting released and you reduce bottlenecks downstream. It's about optimizing the flow of work, not just maximizing how busy individuals look.
Interesting.
Additionally, Lean advocates for maintaining a workable backlog of clearly defined tasks that are genuinely ready to be executed. This ensures a smooth flow. It involves clear task definition and sequence, yes, but critically, it ensures tasks can be performed without penalty for minor deviations or necessary adjustments that inevitably happen in the real world. It promotes efficient workflow and continuous improvement by placing the power of problem solving and adaptation much closer to where the actual work is being done. It empowers workers with the judgment to adapt, leading to greater reliability, higher quality, and much higher worker engagement. It's a fundamental shift from top-down control to enabling the workforce. #C. Communication and negotiation in practice.
So with all these moving parts, different specialists, constant adaptation, how do we ensure communication is actually effective? And crucially, how do we avoid those broken promises on a job site, which must be so damaging to trust and progress?
Yeah, effective project execution, especially in these complex construction environments, relies incredibly heavily on a clear, structured, and mutually understood communication process. This is often referred to as the language action cycle or sometimes a workflow loop.
Language action cycle. Okay.
It's a core idea in reliable promising. This cycle involves distinct, explicit steps designed specifically to prevent ambiguity and ensure accountability.
What are steps?
Okay, first, making a request. Someone initiates a need, states clearly what's desired. Second, negotiating. And this isn't just haggling over price. It's a critical phase where the conditions of satisfaction are clarified. What does done actually look like? Potential obstacles are discussed, maybe counteroffers are made, mutual understanding is achieved. This step ensures both parties are truly on the same page.
Crucial step.
Absolutely. Third, committing. Once negotiation is done, a firm commitment is made by the performer to fulfill that request under the agreed conditions. That's the promise. Fourth, executing the task. The work gets done according to the commitment. Fifth, declaring completion. The performer explicitly says, okay, I'm finished, and it meets the conditions we agreed on. And finally, sixth, declaring satisfaction. The original requester reviews the work and explicitly states whether they are satisfied or not.
That sounds very structured.
It is, and that structure is incredibly powerful. By ensuring clarity and explicit agreement at each stage, it helps prevent broken promises, not just by flagging when they happen, but by proactively making sure commitments are realistic and clearly understood from the very beginning. It significantly reduces misunderstandings, delays, and that erosion of trust. Skipping any step can lead to breakdowns.
And beyond those formal steps, I imagine the human side of negotiation, the emotions, the perceptions, subjective feelings that must play a huge role too, even in what looks like a purely rational business deal.
Oh, absolutely. Tracy Kidder has this fantastic example in one of his books that vividly illustrates these subtle but profound nuances, how human emotions and perceptions of fairness can just override purely rational calculations.
What was the example?
He recounts the situation where a seemingly small $660 reduction in price offered to a client actually made that client uncomfortable and reluctant to accept other, much larger changes that were needed.
Wait, a price reduction made them uncomfortable. Why?
Well, from a purely economic view, the client should be happy, right? Get a discount.
Right.
But in this instance, perhaps that small reduction was perceived differently, maybe as an act of pettiness, or maybe a sign that the other party wasn't willing to truly compromise or value the relationship. It created this emotional barrier that hindered the acceptance of other necessary adjustments.
Huh. Fascinating.
It highlights this critical truth. Contract negotiations are rarely just purely rational calculations of cost and value. They're deeply intertwined with emotional responses, perceptions of fairness, the underlying sense of trust or distrust between the parties. A technically perfect agreement can still completely unravel if that human relationship breaks down, if one party feels undervalued, or if some gesture, however small, gets misinterpreted. Understanding these human elements, the psychology of the deal, is just as important as understanding the legal clauses, because ultimately it's people, not just pieces of paper, who drive projects forward.
So, from those ancient mining codes dictating boundaries and sorting out disputes, right through to modern green building certifications, the complex dance of team dynamics and liability, the law of the job site is just incredibly multifaceted, incredibly complex. But yet, at its heart, it's also incredibly human.
It really is. And this raises that important question. How does an industry that's built on such seemingly rigid rules, precise measurements, formal contracts, how does it also find space for the unpredictable, the informal, the constantly evolving nature of human endeavor? The meticulously drafted documents, the standards, they are absolutely critical, no question. But so too is that daily adaptation happening on the ground. The informal problem solving, the unspoken social contracts that exist between people. There's this constant tension there, isn't there?
Exactly. A tension that shapes our built world in ways we often don't even see. Until maybe something goes wrong. And that's definitely something for you to think about. Final provocative thought. Consider those pervasive implications of informal remodeling and code evasion. All that cob work leading to potentially hazardous wiring, leaky pipes hidden from inspectors in countless buildings. What does this ubiquitous, unpermitted work really tell us about the real-world effectiveness of our stringent legal frameworks when they collide with the adaptive, often pragmatic, sometimes maybe even desperate, nature of human construction practice? And maybe more importantly, how can we, as a society, reconcile these two stark realities, the ideal represented by the code and the messy reality of the informal build, to ensure we get better, safer buildings for everyone, not just for those who can afford or perhaps choose to follow every single rule to the letter?